Okay, so we talked about law of sines because it had the matchup, right? The side and the angle are matched up. Now for law of cosines, we don't have any sides and angles that match up. That's the key here. So in this triangle with capital A, B, and C again, I have sides, little a, b, and c, and it's the same deal where it's across from it, right? It's across of whatever it is I have. Side A squared is equal to b squared plus c squared minus 2bc cosine A. This is literally the same pattern for every single one of these. So it's really not that big of a deal. The side you're trying to figure out, right, is equal to the other two sides squared minus 2 times those other two sides and the cosine of the angle associated with that side. That's all it is. So for B, I rock the socks off of AC to AC, and then the cosine of that B, right? Because that's the side that we're going through. All right. Then, if I want to find side A in the triangle, so here's a triangle that I'm given, and I want to find side A, I am given, right, nothing that matches side B, side C, and an angle A. Nothing that matches up. So, and I don't even have these other two angles in order to be able to figure out the third, right? That's always the beauty of if I'm looking at law of sines, because I can figure out that third angle. Okay, something is matched up. All right, y'all, let's do this thing. So angle A is what I have. So because I have angle A, then I'm going to plug it in here. I've got my other two sides. So I've got 5 squared and 11 squared minus 2 5 times 11 cosine 52. The kicker to this one is the fact that this side over here is squared. When you plug this into your calculator, now in my opinion, I don't care. Put a square root over this whole big mess of stuff up front if you want. Figure out this whole big mess of stuff and then square root it. It's up to you. It's completely 100% up to you. Now, when I'm square rooting this, typically you have to write plus or minus, right? Well, not in this instance because I'm talking about a side, a measurement. Because I'm talking about that, it's always going to be positive. Two significant figures at that 8.9. And that's it. These are just formulas to plug in. The big deal, the big difference between law of sines and law of cosines is law of sines has a matchup for you to do a ratio. Law of cosines does not. But you have all of these formulas that you can pull off. Okay, look at this one. A surveyor wishes to find the distance between 2 points A and B on opposite sides of a lake. Whoop, that. All right. While standing at point C, she finds that AC is 259 meters and BC here is 423 meters, and angle ACB here, right here that she was swiveling, is 132 degrees 40 minutes. We want to find the distance between those 2 points to the nearest meter. Okay, I know this is across from there, so this would be side A, right? Across from angle A. This would be side B, across from B, and you literally plug those in. Plug in everything that you have and be grateful for your calculator. Right? Man, there's no way I would be doing all that stuff. Be grateful for your calculator. Then when you square root it, say, be thankful again. Say another little thank you to your calculator. And you come up with 628 meters. While I'm doing these, just like on all the rest of them, just because I'm talking through here, we're going faster. So pause the video, right? Pause it. Check this, that you get this answer. Then you can start the video up again. Make sure you're pausing the video as we go through here. Okay, let's do some more. Solve this triangle. If I'm given this information, I'm given angle A, side B, side C. No matches, right? No matches. Plug in everything that you know. There's nothing that matches up here. So because of that, and I'm given angle A, go here with A, plug in your BC so that you can get side A. Once you get your side A, because you literally go through and you plug in, right, B squared plus C squared minus 2BC cosine A, then make sure you're still in degree mode, right, this whole time. Then you have A. You just got a matchup. As soon as you have a matchup, check it out, people. Now you can do your law of sines. It is standard practice to go in order. So as soon as you know A, then do your very next one of B. Then C obviously pans itself out. But as soon as you get this match, you don't have to keep going here in law of cosines. As soon as you get the match, it's much easier to switch over and start doing law of sines. My angles are what we have left over we're trying to find. So I put that on top, cross multiply, and I'm dividing by that 10.5 there, because it's like times 10.5 over here, so you just divide it and you can do it all in one step. Here I have 0.81, so that's legit. Inverse sine of that gives me the 53.9 degrees for B. Now I have two angle measurements. A triangle is always 180 degrees, so you can get that set up. All right? So that's the deal. As soon as you have a matchup, revert back to your law of sines, which is why we learned that first, and then you can go forward. All right. Very good. Very good, very good. Let's try another one. Here, I don't have any angles at all. This is the side, side, side situation. So all I know are my three sides. Typically, we start by finding the largest angle. Now, how am I going to know what the largest angle is? Yes, good. It's the largest side. Remember, they match up. So if I have my largest side here of 9, then my largest angle is going to be associated with that largest side. Now, your book. So this is what I'm trying to find is cosine, right? So if I know C here, I'm finding the cosine of C because that's my largest angle. Your book has you go through and solve first. You can. You are more than welcome to do that. Help me solve. This is going to show you how to do that. So it's going to take C squared minus A squared minus B squared divided by a negative 2AB, right? And then you're going to come up with that. And you are 100% welcome to do that, right? Then plug in all your values and figure it out. Or you can plug in all of your values and just work with numbers to pull that off. So A squared, B squared, 2AB, and then this is still what I'm focusing on to get to. 25 plus 36 is 61. 2 times 5 times 6 is 60. Once you get this, you subtract 61 from both sides, right? Which is going to give me a 20. Divide both sides by a negative 60 because I have to get this cosine by itself. And I have cosine of C is equal to a negative 1/3. Still between that negative 1 and 1, right? So my cosine of C is equal to negative 1/3. Plug that into your calculator. Inverse cosine of negative 1/3 is going to be 109.5. As soon as you have one angle, you now have a ratio. And then just keep going on up. So sine of B now is going to be over 6. I have a ratio that I can now work with in terms of sine. So set that up. Cross multiply, and you have B. When you have two angle measures, we know that's super easy then to find the third. And that's the deal. So when you start off with 3 sides, typically you start by finding the largest angle. And once you have that largest angle, then you just work your way back up. So really you're using law of cosines once because it's kind of a whopper of a formula. Then it's much easier to do this nice little rational setup here with your law of sines to get the rest of it. All right. Do you know what just happened? We just finished all the new content for pre-calculus. Well done. Well done, guys. Now practice this material, and this is the last new piece of information this semester. Way to go. Way to go. Nice job.